What I'd like to do now is cover calculating risk. And remember, I want to make some important points that I don't want you to forget and I want you to focus on that statistics match study designs. You heard me say that earlier, and oftentimes people get confused. And then you have to know three table layouts, and I will emphasize those. Otherwise, you're going to come up with the wrong answer. So, um, first point, statistics match study designs, and table layouts match study designs. Okay, so we're going to calculate risk, and we're going to do so for a prospective study. Really, what we're focusing on here is all the observational studies. We're not going to focus on the experiments at all. Those are done usually by biostatistics using some biostatistics subroutine. But I'll try and be as clear as I can for you as we go along. And of course, the Cadillac study, the prospective study, you calculate the most statistics for it as opposed to a case control study, a historical prospective study, or a cross-sectional study. Okay, now, so when we talk about calculating risks, there are two basic terms to know, and these have to do with direct measures of risk and indirect measures of risk. Okay, so you can see that the Cadillac, the gold standard is a prospective longitudinal study, and it is a direct measure of risk. And which is best? Of course, a prospective study. And which is best, direct or indirect measures of risk? Of course, direct measures of risk from a prospective study are the best. So the indirect measures of risk are connected, and you haven't had this yet, but you can just, for right now, you can just draw a line through that and not worry about matched and unmatched cross-sectional study. But you do know about a cross-sectional study. We've covered it: slice of time, questionnaire, interview, whatnot. And we talked about the pink book and how you could get it. And then we talked about a case control study and a historical prospective study. These are all indirect measures of risk. This is the only direct measure of risk. Now, I mentioned that with a prospective study, it has the most statistics. Okay? And with an indirect measure of risk in all these various study designs, we have one measure, one statistic that we do, or one outcome, I should say, because there's two different study designs for the matched and the unmatched cross-sectional study. But you'll see it, and don't let this confuse you. Now, I'd like to talk to you about assessing risk, and remember, we have the most measures of risk for a prospective longitudinal study. Again, that's the best study you can do that is an observational study. Now, it's one thing that you have to recall and remember, that absolute risk is equal to incidence rate. Now, what makes all these terms difficult is their similarity, and we talked about demic before. I know we talked about wholly endemic, we talked about pandemic, we talked about epidemic, and a lot of these terms are the same, and you always hope when you learn something that they're distinctly different. And frequently when we talk about incidence rate, it is not listed. Absolute risk is. So you have to know that absolute risk means incidence rate. And attributable risk is the amount of risk attributed to the exposure. And preventive attributable risk, it has to do with if people didn't engage in the behavior, how much risk would there be? And then relative risk is a matter of how serious the risk is, and we'll talk about how to calculate that. None of the math is difficult. You're going to add and subtract and multiply and divide. So you're going to use basic mathematical functions. So it's not difficult to do. Now, we could do a relative odds with a prospective study, but we don't calculate an odds ratio or a relative odds ratio because the Cadillac statistic that you get is relative risk. And frequently you hear about this on the radio, and most people don't quite know what it means, but you will, and you'll be able to interpret it. You'll be able to read studies. You'll be able to take in information in your field that reports things according to relative risk. And so, again, relative odds ratio can be calculated, but not done because relative risk is the gold standard. And I want you to also note that all formulas require the use of absolute risk or incidence rate, or the number of new cases divided by the population at risk times K. So that's the same formula you learned from the beginning of class when we were talking about incidence rate. There's nothing new. We're just talking about applications and study designs. Now I want to talk to you about a case control study, which is an indirect measure of risk. I know I'm being redundant, but I'm being redundant on purpose. And the only statistic we can calculate 1, 2, 3, 4 statistics from a direct measure of risk or a prospective or longitudinal study, and we are going to calculate one measure of risk from the other observational studies. So if we talk about an odds ratio, also known as the multiplication of cross products, right here, you'll see how quick and easy that is to do. And cross-sectional and historical prospective studies also use an odds ratio, and an odds ratio is similar to relative risk, but it's not as accurate an estimate of risk, and so, but it's the only calculation that can be made from a indirect measure of risk. Okay, so now I want to let you know here, when we deal with cross-sectional studies, there are two types. We talked about matched and unmatched, and you still get an odds ratio from them, but you calculate them in a different way. And there's three tables in their layout that you have to attend to in order to do the correct calculations. Okay, the first one I'm going to start with, of course, you've had enough exposure to these lectures, is I'll peel it like an onion. I'll go right through it one after another, so you shouldn't be confused about it. Now, notice, when we have a prospective study, we have disease develops, right? Disease is not developed because we're following them over time. And then we have exposure, exposed and not exposed. And if we're going to calculate absolute risk or incidence, that's A divided by A plus B, and that's the incidence in the exposed group. And we're going to, all calculations are done with absolute risk. And you can see the absolute risk for the exposed group and how to calculate it, and the absolute risk from the unexposed group and how to calculate it. Now, I have said nothing new to you because you know how to calculate absolute risk or incidence rate. Okay? Now, relative risk is calculated with absolute risk, or the incidence rate among the exposed individuals, and the incidence rate among the non-exposed individuals. So that's information you're going to get from here and here. Now, please take a mental snapshot of this particular table and notice how every one of the cells are labeled, because you're going to need to know that. And remember, the key thing to remember is absolute risk is just another name for incidence rate. Okay? So I'm assuming we're together thus far and you're not confused. Now, attributable risk. This is, I don't know, some people have trouble with this. I'm not certain why, but I'll try and make it as clear as I can to you. And you should not be confused by it, because we've already gone through a problem similar to this, and I will refer to it, and I hope I refer to it in a simple, unconfused way. Some subjects exposed to a factor will not develop the disease. Okay? You can say they have an immunity, right? Or they received an injection. Some subjects not exposed to a factor will develop the disease. Now, I want you to recall how we computed the secondary attack rate for the foodborne outbreak in Oswego, New York, Lycoming, Oswego, New York, and what you observed in the line listing when you began to count cases. If we looked at the first page, most who ate the food became ill. But when you looked at the second page, some people who ate the food did not become ill, right? So some who ate the food became ill, and others who ate the food did not get sick. So you're already used to this kind of thinking, and this is typically what happens, and people get concerned that this means that there must be something the matter either with the study design or the cases or whatnot, and this is just normal behavior with an illness. Okay, now hope you have that firmly in mind and you're comfortable with it. Attributable risk, the amount of risk attributable to the disease. Okay, and attributable risk and proportion of attributable risk for a group. Now, with doing a prospective study, we're going to do group statistics and population statistics. So you have two sets or two different types of statistics to do, and one set of statistics builds on the other. Okay? Now, we've already talked about attributable risk, also known as incidence ratio. So attributable risk, the proportion of a disease attributable to a particular exposure. Let's go over this slowly. For example, in a population of smokers, how much of the lung cancer is associated or attributed to smoking, and consequently how much of the lung cancer could have been prevented if they did not smoke. Okay? So we want to focus on the work group, for example, because we're going to do the same type of statistic um, again for estimating population risk and ascertain whether our group is representative of that population. And don't worry too much about what I've said. You'll see it unfold before you. And then we'll look at the proportion of attributable risk is also referred to preventive attributable risk. So there's two terms here. So you can think of proportion or preventive attributable risk. Both terms are used for this particular calculation. I use proportion because we're going to calculate a proportion. And we know when we calculate a proportion, whatever is in the numerator is repeated in the denominator. Okay? But this statistic has to do with how many cases or what proportion of disease could be prevented if people did not engage in the behavior. So that's what we mean by preventive attributable risk, okay, or proportion of attributable risk. Now, let's go slowly through these. Now, notice how complicated the statistics are. So, you're going to look at attributable risk. Now, absolute risk, or the incidence rate in the exposed group that is attributable to the exposure. So we're going to take the incidence in the exposed group minus the incidence in the unexposed group, and that's going to give us attributable risk, AR. Now these are group statistics. Just remember that. So we have proportion of attributable risk, and we said this could be preventive attributable risk, and it's a proportion of the absolute risk or the incidence rate in the exposed group that is attributable to the exposure. So we're going to take these two up here and we're going to divide by the incidence in the exposed group, because that's the way we know a proportion operates. Okay? And then we're going to note certain aspects, and I want to begin to show those to you. Okay, now I'm introducing you to a specific problem, and this is a group and not a population calculation. Okay, to get attributable risk, absolute risk or incidence rate, and this is for a prospective study, so you have memorized all of these cells and know what they mean and how to label them, because you're going to label them different when you do an odds ratio. Okay, so we have a group of healthy smokers and healthy non-smokers, and those that developed coronary heart disease was 84 over 3,000, which was 28. Okay, so the absolute risk is 28 per thousand. Okay, for healthy smokers. The absolute risk for healthy non-smokers is 87 divided by 5,000, which is 17.4 per 1,000. Okay, now I want to show you how I did the calculations. Okay, there they are. That's just what I've told you. Now you could change this from incidence rate among exposed or incidence rate among non-exposed to absolute risk. That's the absolute risk. So we can in fact, I'm just going to make a modification, and that's how we would do it. So we want to know the incidence rate or the absolute risk in the exposed group attributed to the exposure of smoking. So what we do is we just subtract the absolute risk in among healthy smokers from absolute risk among healthy non-smokers, and it's 10.6 per thousand per year. Now, what's the proportion of total incidence or the incidence rate in the exposed group attributable to the exposure? So the same thing, we go the same way, and we're going to come out with a percentage in this particular case, and that I didn't emphasize before, but you know it's a proportion, so you know it's going to be expressed as a percentage. Now notice a proportion that if they didn't engage in the behavior, what it would do. Okay, so 37.9% denotes the morbidity from coronary heart disease among smokers. There would be, and here's the key, and you hear this on the radio all the time. If you listen to study results, if you're driving through Indianapolis or other big cities, or sometimes on national news, you'll hear the same information, and they won't go into some of the more nitty-gritty details, but they often will report this, and they would indicate there would be a 37.9 reduction in the incidence rate of coronary heart disease if smoking were eliminated. Now I'd like to introduce you to a specific problem related to a prospective or longitudinal study. And again, I want you to focus on the layout of the table as I mentioned before, and I want to go slow through this so you're not lost, and I'll show you how I do my calculations, and they're not difficult. But if we were going to come up with absolute risk, we'd divide 84 by 3,000, and it would be 28.0 per thousand per year. And if we were going to do absolute risk for healthy non-smokers, it would be 87 divided by 5,000, or 17.4 per thousand per year. Now, here's my calculations. And I'll show you how I came up with those answers. Okay, so you ought to be able to replicate that, and it's always the same. So, and if you want to make it more complete, you can put another slash and put year on the end, as it's shown in the next one. Now I want to talk about attributable risks, the amount of risk attributable to engaging in the behavior. Okay, so we have incidence rate or absolute risk in the exposed group that's attributable to the exposure or smoking. So the additional or the risks that you take, or anyone in your family takes, or your friends take when they smoke, according to this data, is 10.6 per thousand per year. Okay, and we'll talk more about these so you can translate them, and you know that risk is relative to a population, and that this is a hypothetical population, so you can say, well, if we had a hypothetical group of 1,000, 10.6 would be at risk if they smoked. Okay, now we look at the proportion of total absolute risk and in the exposed group attributable to the exposure. And again, we've used a proportion. It's reported as a percentage. That's why I prefer the word proportion, as I mentioned before. You can see the calculations, not too difficult. And the 37.9 denotes the morbidity from coronary heart disease among smokers. There would be a 37.9% reduction in incidence, the incidence rate of coronary heart disease if smoking were eliminated. Okay, now, um, this is a statistic you often hear on the radio or on television, or when they're trying to promote um, the results of a study and telling you the benefits of it. And so proportion of attributable risk is one that you hear a lot, along with relative risk. And we haven't covered relative risk, and it's the main one, it's the main statistic that you will hear most often. Okay? So we've covered most of those calculations, but we'll get to relative risk here in just a minute. Now, the most difficult for people is attributable risk, and I don't really understand why, but whether I do or I don't doesn't make any difference. It's whether you understand why. So if you look, I'm going to go through this. This is the amount of risk in that we calculated, or the absolute risk. And the absolute risk in the exposed group was 28.0, right? So you can just put 28.0 here. And then the amount in the unexposed group was 17.4, and you can put that there. Now, if you subtract, which we're going to do, this is the unexposed group, and this is the number of people who are going to become ill even though they didn't smoke. They're going to develop lung cancer even though they didn't smoke. And so we're going to subtract these two, and this is the attributable risk to smoking right here, not this. This is the baseline amount. So what is the amount of attributed to the condition or disease? That would be this amount, or 10.6, right? Because we subtracted this 17.4 from 28.0, and so we came up with 10.6, and that was the attributable risk per 1,000 per year. So this is the amount attributed to engaging in smoking. Okay? Now I hope that's clear, and that you don't have any trouble comprehending what we're trying to mean by attributable risk. I know when I first learned this, once I saw the diagram, I understood exactly what attributable risk meant. And if you think about the line listing for the foodborne outbreak, you can see that some people don't get sick, and some people do. Okay, so this is these people have gotten sick, and we subtracted them out. Okay. Now, I told you there was, with the prospective study, there was group statistics and there were population statistics. And we have to obtain data from a secondary source to do population statistics. And I want you to go through this carefully with me so you understand it. This data came from Healthy People 2020. We could have used other sources from the U.S. Department, which is from the U.S. Department of Health and Human Services, or we could have used other sources such as Back to the Future, which is a research group at the University of Michigan who has looked at all kinds of health risk behaviors for a long time, including smoking. All right? So, what we're trying to do here is we're trying to see, we used a group from Purdue that we selected previously. We used a group of students, so now we're trying to determine, do these group of students or people that we have selected really represent the nation at large, or is there something peculiar about them? Okay? Now, if we look at population statistics, which I think this is pretty interesting in terms of the percentage of people who smoke and whether it's changed a lot over the years, and you can see that the the percentage who smoke in the total population is 20.6 in 2008, 20.6 in 2009, 19.3 in 2010, and 19 even in 2011. So if I was going to ask you about a trend, that's a linear line, isn't it? There's little variation in the percentage of people who smoke. In other words, you could tell me, well, 1 out of 5 people in America smoke. That would be a simple way to say it. And then you could go down and you can say, well, who smokes the most? If we look at race, ethnicity, which is an important factor, who amongst these groups smokes the most or who smokes the least? Now let's look at just, this is really interesting for Asians. They tend to smoke the least, and it hasn't changed. Looks like there was a little spike, and this is probably an anomaly. I would have a question about why we got a higher value in 2009 than we did in any of the other years. Okay, and in the DSU indicates that the data is statistically unreliable, and that's why they didn't include it. Now, let's go down and look at Black or African American only, and you can see their smoking rates. And there's a slight drop, but it's not a major drop. And you can see that probably you would conclude that black and whites smoke just about the same amount, same percentage.